Okay, so from this, okay, from this magnitude, okay, magnitude of the transfer function and also the phase of the transfer function. Okay, so now, okay, we can see, okay, the output, okay, the output waveform, okay, from the magnitude, and also what is the curve, okay, for the phase of this transfer function. Okay, so we're just looking on the critical point, okay, which is when omega is equal to 0. Okay, you substitute when omega is equal to 0. Okay, so you will get, okay, your magnitude is equivalent to 1 when you put your omega is equal to 0. Okay, so you will have magnitude of 1. Okay, or the angle, okay, when you put your omega is equal to 0, okay, so you will have, okay, the phase is equal to 0. Okay, so when you put omega is equal to infinity, okay, you substitute your omega is equal to infinity, okay, so you will get 1 divided by infinity, okay, we will give you the magnitude is equal to 0. Okay, same with your phase here. Okay, you substitute, okay, your omega with infinity. Okay, the tangent infinity tangent, it will give you, okay, the theta is equal to minus 90 degree. Okay, so another critical point is omega is equal to omega naught. Okay, so it will give you, okay, square root of 2, 1 over square root of 2 is, your magnitude is 0.707. Because when your omega divided by omega naught, okay, when there are the same values, okay, so you get here is 1. So 1 times 1, 1 plus 1, it will give you 2, right? So 1 over square root of 2 is 0.707. Okay, and then your minus, okay, inverse tangent of 1 will give you minus 45. Okay, so which these or a few points that we find, okay, so you can sketch the response of it. So when 0, okay, the magnitude is 1. Okay, when you have your infinity, okay, omega, so we will give you your h which becomes 0. And then this is the point when your omega naught is equal to omega, okay, and the magnitude is 0.707. Okay, so this is the sketch for your phase. Okay, when your phase, okay, at omega is equal to 0, so it will give you, okay, 0 angle. Okay, however, okay, when your omega is equal to omega 1, okay, while your omega is equal to omega 1, it will give you, okay, the angle of minus 45 degree. Okay, for the angle of omega is equal to infinity, okay, your angle will be minus 90 degree. Okay, so this is a sketch. Okay, okay, so after that, okay, we go to the third example. Okay, so now we have to obtain, okay, the transfer function, okay, of omega V out divided by Vs of the RL circuits shown below. Okay, assuming the Vs, okay, is equal to Vm cos omega t, and sketch its frequency response. Okay, so for these circuits, okay, you have the series R and L circuits. Okay, so in first place, okay, so you just replace your R with R, and then your L with J omega L, and your capacitor with 1 over J omega C. Okay, so you replace the circuit, okay, with this, okay, frequency domain equivalent circuits. Okay, and now okay, we go to the transfer function derivation. Okay, so you have V out here. V out is your voltage, okay, across your inductor. which is I times with j omega L. Okay, your Vs is the total of voltage across your R plus with the voltage across your inductor. So it's your I times with R plus j omega L. Okay, so we can divide the numerator and denominator by 1 over j omega L. So you will gain 1 here for the numerator. Okay, for the denominator is becomes 1 plus R divided by j omega L. Okay, because we try to represent this transfer function into 1 over the real and the imaginary part. Okay, so possibly the imaginary part become 1. The real part become 1. Okay, 1 with plus with j or imaginary part. Okay, all right. So your transfer function is V out divided by Vs. Okay, so we have 1 over 1 plus R divided by j omega L. Okay, so now we want to have the magnitude of your transfer function. Okay, so same with previous one. Okay, so your magnitude is 1 over the square root of 1 squared plus with your imaginary one. Imaginary terms is R divided by omega L squared. Here we assume your omega naught is equal to R divided by L. Okay, and then your magnitude now when you substitute your R divided by L is equivalent to omega naught. So your magnitude is 1 over square root of 1 squared plus omega naught divided by omega squared. Okay, and also equivalent to 1 over square root of 1 plus omega naught divided by omega squared. Okay, for the angles, because they are the RL circuit, so the inductor, the imaginary part is positive. Okay, so we have the omega naught divided by omega is on positive side, so you have the positive angle. Okay, so it's the inverse. Is the inverse of tangent. Inverse of tangent. Okay, the imaginary. The opposite is omega divided by omega naught divided by the behind. The behind angles. Because we know tangent is opposite divided by behind. So omega divided by omega naught divided by 1. So which is also equivalent to the inverse of tangent omega divided by omega naught. Okay, so this is the phase. Okay, so now we can substitute similarly with our RC circuit just now. Okay, so you plot at omega equal to 0. When omega is equal to 0, you substitute omega with 0. So you will get your H is equal to 1. Okay, when you substitute your omega is equal to infinity. So this is the omega equal to 0. When you substitute I repeat again. When you substitute omega equal to 0, so what you get for the magnitude is 0. Then when you substitute omega equal to infinity here, so you will get your magnitude equal to 1. When you substitute your omega equal to omega naught, so you will get your magnitude equal to 0.707. For the phase, curve, when you substitute your omega equal to 0, you have the tangent 0. We give you tangent 0. We give you 90 degree. Inverse of tangent 0 is 90 degree. And when you substitute your omega, okay, with infinity. Okay, so you can get your angle at infinity is 0. Okay, when your omega is equivalent to omega naught, so you will get, okay, the angle is at positive 45 degree. Okay, so you can have a try. Okay. All right, for this exercise 1, okay, calculate the gain, okay, I naught omega divided by I in omega, okay, and it pulls as zeros. Okay, the answer, okay, is zeros give you, okay, 0, and Z2 is give you, okay, the zeros will give you 0 and minus 2, and the poles is the repeated poles, okay, is at negative 1. Okay, so the first step you must taken, okay, is to get the frequency domain equivalent circuit. Okay, so you replace your R with R, your L with J omega L, your C with 1 over J omega C. Okay, so the transfer function is I output divided by I input. Okay, so we can get your I output by using the current divider rules here. Okay, so from the current divider rules, okay, so your I here, okay, is your Z here divided by the Z total. Okay, so your Z, okay, at this branch is 4 plus J2 omega, okay, divided by the total of Z is 4 plus J2 omega, okay, plus with 1 over J 0.5 omega, okay, times with your supply current. Okay, and then you bring, okay, your supply current here to get the transfer function. Okay, so what you left here is 4 plus J2 omega divided by 4 plus J2 omega plus 1 over J 0.5 omega. Okay, and then, okay, now you simplify. Okay, so we'll give you, okay, from 4 plus J2 omega divided by 4 plus J2 omega plus 1 over J 0.5 omega. Okay, so we bring, okay, we convert here, okay, 1 over 0.5, it becomes 2 divided by J omega. Okay, and then you can, okay, go for your, okay, cross multiplication at the denominator side. Okay, so you will get, okay, the denominator 4J omega, okay, plus with 2J omega squared, okay, plus 2. Okay, and then you bring up this J omega outside. Okay, so we will give you 4 plus, okay, for this multiplication of this, okay, numerator side. Okay, we give you 4J omega plus with 2J omega squared. Okay, and then just let your S is equal to J omega, so you replace the J omega with your S. Okay, so what you have now, okay, is 4S by replacing the J omega with S. So you have 4S plus 2S squared divided by, okay, 4S, okay, plus with 2S squared plus 2. Okay, you can still simplify. Okay, you bring out, okay, your 2, okay, your 2 constant here, so it becomes, okay, S2 with times with your S squared plus 2S. Okay, and you also bring, okay, the 2 outside, so we become S squared plus 2S plus 1. Okay, and then here, okay, so, okay, you get, okay, from S squared plus 2S, okay, you simplify using calculator. Okay, so you will get S, okay, in bracket S plus 2, okay, divided by, okay, the denominator side will give you S plus 1, okay,